Let's say we have this screenshot of my game Mechafrost. If we add a little bit of noise to this image, noise is basically just random pixels, by the way, then the question is, how could we restore this original image? Well, we can start with a blur. But what even is a blur? Is it this? Let's first look at a 1D function that describes a noisy image. If we want to blur out the noise, we can do it like this. This is basically keeping higher frequencies while removing lower frequencies. Now if we add these two functions together, we get this function. And now we keep the lower frequency while removing the higher frequency. This is called a low-pass filter. It removes higher frequencies based on the cutoff frequency. Now let's think about how to do this in an image. We can effectively smooth out little details in data by averaging out the results. But we can't just average out the whole image because that will end up looking like this. So let's zoom in even more to a grid of 9 pixels. The color of this top left pixel is represented by RGB values: red, green, and blue. Now if we add up all the individual RGB values and divide it by 9, then we can get the average value in the center pixel. If we then do this for every pixel in the image, we get a box blur. There might be some box-like artifacts, since our smoothing function is literally a box. We can solve this problem by smoothing out the smoothing function in order to get a Gaussian function. The standard deviation measures how wide the function is. If we look back at our cutoff frequency, it is determined by the standard deviation combined with the kernel size. By the way, a kernel is the 3x3 grid of values we looked at earlier. Let's get back to that now. If we visualize this in 3D space, a box blur is essentially multiplying all pixels by 1/9 and then adding them up. The 1/9 here is called a weight. Now how can we integrate the Gaussian function here? We can adjust the weights so they're in the shape of a Gaussian function based on the distance from the center pixel. And then as with the 1/9, we multiply each pixel by its corresponding weight and then add them all together. So here are our weights on the 2D kernel. They add up to 1 as with the 1/9. So if we think about it, the Gaussian blur is actually just a box blur but more concentrated towards the center. If we now do this for every pixel in the image, we get this result. This is the Gaussian blur but with a much larger kernel. This is essentially the same as taking the convolution of the Gaussian kernel with the original image. For more information about convolutions, you can watch 3 Blue 1 Brown's video on the matter. So this is our final Gaussian blurred image. As you can see, there's a great loss of detail and edges. I'll make a video about non-linear denoising techniques next.